So the third and final part of this lesson, in this section, has to do with the average rate of change of a function over an interval. Those of you who are going to be going into calculus, you're going to see that this is going to be pretty important. But the average rate of change is basically the change in the function divided by the change in x, if x is the independent variable. And graphically what it represents is the slope of a line that passes between 2 points on the graph, where these 2 points correspond to the endpoints of your interval. So if we want we're given the interval a, b, we want to find this line, which we call the secant line, or rather we want to find the slope of this line, and that number is the average rate of change. The coordinates of this point would be f of b, would be this coordinate here would be b comma f of b. This would be a comma f of a, and we just compute the slope of the line as we usually do. So this looks like a new formula, but actually it's just we're just finding the slope of a line, and it's just that this line depends on this particular interval as well as this function. Okay, so it's really just a matter of plugging stuff in. And again, this will be a lot more used a lot more in calculus if you're taking calculus next semester or next year. So if we wanted to find the average rate of change of this function f of x equals x squared on the interval 1, 3, this would be f of 3 minus f of 1 divided by 3 minus 1. Okay. Plug in x equals 3 in here, we get 9. Plug in x equals 1, 1 squared is 1. 9 minus 1 is 8, 2 minus 1 is 3 minus 1 is 2, 8 divided by 2 is 4. Okay. You might want to pause the video and try these next two examples. This would be g of 5 minus g of 1 divided by 5 minus 1. Plug in 5, we get 1/5. Plug in 1, we get 1. Right, because 1 over 1 is 1. And 5 minus 1 is 4. Do a little subtraction. This is 1/5 minus 5/5 is negative 4/5. And this is the same thing as negative 4/5 times 1/4. 4's cancel. And we get negative 1/5. And lastly, if h of x is defined this way, this would be h of 3 minus h of 2 divided by 3 minus 2. Okay, you can compute h of 3 separately if you want. H of 3 is going to be 3 cubed minus 2 times 3 is 27 minus 6. So this would be 27 minus 6, 3 minus 2. This would be 21. Oops, I'm sorry. 27 minus 6 minus, then this would be 8 minus 4. I jumped ahead of myself here. And then this becomes 21 minus 4 over 1, which is 17. Okay. So that's the average rate of change. That's pretty standard. We're going to see in calculus how if you take the limit, if you fix a and let b get closer to a, it turns out that these rates of change actually converge to a certain number, and that leads to the idea of a derivative. But again, that will be something that you'll explore in calculus.